All right. So today we're going to keep talking about volume. Just a little review on volume of a prism. So here we have what's called a hexagonal prism. And remember, volume for any prism is area of the base times the height. So what makes this problem difficult is, well, our base is a regular polygon. So remember, the area for a regular polygon, like this hexagon, is going to be 1/2 apothem times perimeter. Okay, so the tricky part is obviously finding the apothem here. So if you draw the apothem right there, we can make a little right triangle out of it. So obviously if it's 2 across, this would just be a 1. Now we need this little angle here. Okay, so if you remember a central angle, we would have 6 of them since it's a hexagon. So 360 divided by 6 is 60 degrees, which means this angle right there at the top is half of that, so 30. So we need to find the apothem right here. So a couple ways we could do that. So we could use our 30, 60, 90s, right? So this would be the short leg, it's across from 30. So times root 3 would get our long leg here. So A is square root of 3. Or you could do, tangent 30 equals 1 over A and solve it that way. That's fine as well. Perimeter, that's pretty easy. Each side is 2. So 2 times the 6 sides would give us a total of 12. Half of 12 is 6. So 6 root 3 would be the area of our base. And then the height of the prism is 5. So that would be 30 square root 3, which if we want the decimal, we'll go plug that in our calculator here. So 30 and square root 3. So decimal is about 51.96 if we go 2 decimal places. And we would be in feet cubed. All right, so that was a prism. Today, we're going to talk about cylinders. Nice thing about cylinders, they have the same volume formula, area of the base times the height. The only difference with the cylinder is that our base is a circle, right? So anytime we're finding B for a cylinder, we're going to be using pi r squared, okay? Again, only for a cylinder. So if we want the volume of this cylinder here, so area of the base times the height. So B, we get pi r squared. R is 5. So pi times 5 squared, and then a height of 21. So pi times 5 squared times 21. So pi times 5 squared times 21. And so we get 1,649.34. And we're in feet cubed again. So not too complicated. Another example, so again, volume equals area of the base times the height. So again, for area of the base, we got to use pi r squared. So pi times 3 squared. And then the height of the cylinder is 12. It's always the distance between the bases. So again, we'll plug that into our calculator. So pi 3 squared 12. And so 339.29 millimeters cubed. Okay, going on to the next problem. So here we have, looks like a rectangular prism. Well, I guess it'd be a square prism. They should have really marked these. So we'll say it's 48 by 48 with a hole drilled out of it. So volume is everything inside, right? Well, this is empty in the middle. So what we have to do is find the volume of the prism. So to do that, it's area of the base, so 48 times 48 times its height of 18. So that would be the volume of the big prism. So 48 times 48 times 18. Probably going to be a big number. 41,472. We got to find the volume after we drill this hole out of it. So we're going to need to subtract and then find the volume of this cylinder. So remember, that's area of the base. So since the diameter is 9, it's going to be pi, the radius would be 4.5 squared, and then its height, which is 18. So pi times 4.5 squared times 18. It's going to get us an answer of 1145.11. And then, so then our total, when we subtract, so 41472 minus the 1145.11. So 40,326.89. And centimeters cubed. So that's how you do that one, just with some subtraction. Next, we'll talk a little bit about Cavalari's theorem. Nothing really hard. Just says if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So basically it's saying you can take like a cylinder or a prism and kind of like essentially you tilt it. As long as the heights remain the same, they're going to have the same volume. It's really all that is. So real simply, if we wanted the volume of this, it's a prism. So area of the base times the height. So our area of the base is 5 by 5, so 25. And then times the height. Now the height isn't 17 because that's slanted. So we got to find this height right here, which we'd have to use some Pythagorean theorem. So h squared, 289 minus 9 would be 280. We're going to have to take the square root of 280. Well, let's just write it as square root of 280 and we'll calculate it at the end. So 25 times square root of 280. And our volume, it's going to be about 418.33. Oops. And again, inches cubed. So that's what we're doing today, primarily volume of cylinders, adding that with what we did about prisms, and then Cavalari's theorem. So again, pretty short assignment. I do want to see, some work. So, rather than just put an answer, at least show me what numbers you're multiplying to get your answer. That's good enough for your work there. So there's your assignment.